Welcome back to our YouTube channel, Statisticians Hub. Today, let us understand how to do Latin square design in IBM SPSS software. So, let us first understand what is a Latin square design. So, Latin square design is an experimental design which says it is a method of placing treatments so that they appear in a balanced fashion without a square block or field. Treatments appear once in each row and each column. Treatments are assigned such that each treatment appear only once in rows and columns. Number of rows, columns and treatments should have been equal. So here is the form of how does a Latin square design looks like. So as you can see that it is an example of a 4x4 Latin square design. Here 4 separate columns and 4 separate rows are present, with respect to which each row and each column possesses a specific treatment, where T1, T2, T3 and T4 are 4 different treatments. Where we can see that no 2 treatments are into the same column or in the same row. Mathematically, we can see that if we suppose T1, T2, T3 dot up to Tm are m treatments which are applied to m rows and m columns. Let Yijk be an observation in the ith row and jth column and receiving the kth treatment. Then the expression of the term can be written as Yijk is equal to mu plus alpha I plus beta j plus gamma k plus epsilon I j k, where mu is the general mean effect, alpha I is the effect due to ith row, beta j is the effect due to jth column, gamma k is the kth treatment effect, and epsilon ijk is the error effect. Now we have an example here. It says there are 4 cars available for this comparative study of the tire performance. It is believed that tires wearing out in a different rate at different location of a car. Tires were installed in 4 different locations of a car. So here tires are arranged or placed in 4 different locations of a car, namely right front, right rear, left rear. The measurements of the wearing of the tires in this investigation are listed in the following table from a LSD setting. So here we can see that the columns denote the positioning of the tire, rows denote which car it is, car 1, car 2, car 3, car 4, and the treatment are the different tires, different brand of tires, say A, B, C and D. And here are the measurement of the tire wearing, that is how much weared the tire is. Let us now construct the null hypothesis as well as the alternative hypothesis. So in this case we need 3 different hypothesis scenario. The first one is H01 is the first null hypothesis, which says there is no significant difference in average tire wearing between different tire positions. Against which the alternative hypothesis H11, which says there is a significant difference in average tire wearing between different tire positions. H02 is the second null hypothesis, which says there is no significant difference in average tire wearing between different car used. Against which the alternative hypothesis there is a significant difference, and so on. Thirdly, H03 is the third null hypothesis, which says there is no significant difference in average tire wearing between different brands of tire. Against which the alternative hypothesis H13 says there is a significant difference in average tire wearing between different brands of tires. Now we move into the IBM SPSS software. Here are my 4 different variables, where the first variable says car, that is the car model, position, that is the position of the tire, that is the tire model or the brand of the tire, and tire wear, which is the measurement. Every variable is of type numeric with width 1, 1, 1, 2 as first variable, second variable, third variable. Each one of these are categorical variable. Here I categorize as the first variable car, which says 1 equal to 1, 2 equal to 2. That is the different cars. That is 1 is 1, 2 is 2, 3 is 3, 4 is 4. click on OK. Now the positioning. Here 1 means RF, that is right front, 2 means LF, that is left front, and so on, 1, 2, 3, 4. I click on tire. It says 1 equal to A, 2 equal to B, that is the different brands of the tire A, B, C and D. Now if we move into the data view, we can see that here are my data printed, already printed here. Now I go to analyze, go to general linear model, go to univariate here. I click on tire wearing rate, that is the tire wear measurement. Take it to the left to the right under the dependent variable and take all the other factors under fixed factor. Now I need to go to model here. I click on model, go to custom and then take each of the variable from the left to the right one by one. If I select 2 at a time, let me show you, and take it from the left to the right, you can see that there is an interaction effect occurs. But I don't need this, as we only deal with the main effects. I select the main effect here, click on continue and now click on OK. Let me take it to the full window. Here you can see that 2 different table appears. So this table is not in our concern. Our concern is about this table. Here you can see that different p values of different variables has been occurred. But it can be also seen that the 3 different variables, that is car, position and tire, each one is significant. That is, from this table it can be concluded that p value for all the 3 variables are significant. That is less than, p value is less than 0.05. So we reject our null hypothesis and conclude that there is a significant difference in average tire wearing between different cars used, different tire positions, different brands of tires. But we need to check which factor is affecting the most. So now for this, we again need to go to analyze, go to general linear model here, click on univariate. This window appears again. We don't need to change any of the variables from this and directly go to post hoc here. We take all the variables from the left to the right and click on Q key, that is check the box which says Q key, click on continue and click on OK. So this is the first table which already appeared and we discussed about this earlier. So this is our post hoc results. You can see that there are 6 different tables appeared here. So now let us understand one by one. This is the first table which is for the different car models, and it is seen from the table that all the values are significant. That is, no 2 car models are insignificant. Car 1, car 2, car 3 and car 4 all are significantly different from each other. From the second table, that is position of the tire, it says all the values are significant. Here also, as the p value for all the different variables is less than 0.05. That is, no 2 positions are insignificant. And this is for the different tire model, that is A, B, C and D. Here just the tire A, that is the tire model A and tire model B, these 2 are insignificant, otherwise all the values are significant. Here it is also written that brand A, C, A, D, B, C, B, D and C, D all are significantly different from each other except for model A and model B. So this is how we do Latin square design in IBM SPSS software and conclude it. So that's all from my side. If you have any query regarding this topic, you can comment down. Also, please make sure to hit the like button and subscribe to our channel. Thank you.